In the first set of lectures about correlations, I reviewed the Pearson product moment correlation coefficient and the Spearman-Rho correlation coefficient. Remember that the Pearson product moment correlation coefficient requires interval or ratio data for both the x and y variables, whereas the Spearman-Rho correlation coefficient applied to ranked or ordinal data for an x or y variable. And it's often the case that your data variables are not going to be the same level of measurement, and you may have data that is interval or ratio, but also data that's categorical. So in addition to correlation coefficients based on the Pearson product moment coefficient, there are coefficients which instead use measures of association and incorporate categorical variables. In this lecture's lesson, you're going to know how to compute and interpret the Point-Biserial Correlation Coefficient and test for significance using SPSS, including how to write the variable in APA style, or write up the analysis in APA style. You'll also know how to compute and interpret the partial correlation coefficient and test for significance using SPSS, as well as how to write your interpretation in APA style. So let's begin with the point-biserial correlation and what that is. A point-biserial correlation is used to measure the strength and the direction of the association that exists between one continuous variable and one dichotomous variable. It's a special case of the Pearson's product moment correlation, which is applied when you have two continuous variables, whereas in this case, one of these variables is actually categorical with only two categories. So the continuous variable is measured at the interval or the ratio level. Examples of variables that meet this criterion include revision time, such as measured in the hours of time needed to edit or correct a document, intelligence by measuring your IQ score, exam performance, measuring the score from 0 to 100, your weight measured in pounds, and so forth. Examples of a dichotomous variable would be gender, because a person can be male or female, or if you're thinking of it as a researcher, you could place your participants in an experiment, and a set of participants would be in an experimental group, or they would be in a control group. When you think about the dichotomous variable, it has to be an either or situation. The participant cannot be in both categories. And aside from the types of scales involved, the interpretation of the resulting coefficient is very similar to that of the commonly reported Pearson product moment correlation coefficient. In brief, like the Pearson product moment correlation, the point-biserial correlation can range from 0 to +1 if the scales are related positively. That means that both of the variables are in the same direction. And from 0 to -1 if the two scales are related negatively. That means they're in opposite directions. When one increases, the other decreases. So the higher the value of the point-biserial correlation, either positive or negative, the stronger the relationship is between the two variables. Now I'm going to share with you some examples of the types of research questions that you could answer with a point-biserial correlation. So does gender have an influence on one's salary? Or what is the relationship between gender and job satisfaction of extension agents? Or what is the relationship of marital status and job satisfaction of extension agents? And you would see in the first two questions, your dichotomous variable is gender, male or female. And your third question, it's marital status. So it would be measured with only two categories, either married or not married. And so let's think about this. In your survey, if you were to ask a question, what is your marital status? You could ask a variety of answer choices from single, divorced, married, complicated, whatever it might be. So what they would do is they would have one category that's the not married, and then they would take all the other and they would put all of those choices like divorced, single, it's complicated, into that one category, not married. And then they would have the category married. And then that's how you could measure that question. Just as you would check the sources of bias for the Pearson product moment correlation coefficient or the Spearman-Rowe, you need to do the same for the point-biserial correlation. So when you choose to analyze your data using a point-biserial correlation, the process involves checking to make sure that your data can actually be analyzed using a point-biserial correlation. So you need to do this because it's only appropriate to use a point-biserial correlation if your data passes the assumption that first you have one dichotomous variable and one categorical variable. Then there should be no outliers for the continuous variable for each category and for each category of the dichotomous variable. And you can test for your outliers using box plots. And then your continuous variable should be approximately normally distributed for each of the categories of the dichotomous variable. And you can test this using the Shapiro-Wilk test of normality, which you will get when you do the Kolmogorov-Smirnov test for normality. And that is interpreted the same as the Shapiro-Wilk test. Then your continuous variable should have equal variances for each category of the dichotomous variable. So you can test that using the Levine's test of equality of variances. Now you might wonder what you have to report in APA after you've done your analysis in SPSS. You need to pay attention to your correlation coefficient. If you've used the bootstrapped confidence interval that Andrew Fields discussed in the book, because it can make your data more robust, and then your significance level. And what you're really looking at is whether the relationship between the two variables is significant or not significant. So I'm going to demonstrate this now with one of the examples from the book. Now, task 2 at the end of your textbook uses the data file chick-flick. And it's from your projects in chapter 3 that I demonstrated in your lectures. You're going to use the chick-flicks data file, and we are going to find out if there is a relationship between gender and arousal. So gender is your nominal variable that has two categories, male and female. And then your psychological arousal during the film is actually a scale item. So let's take a look at how this works in SPSS. So for task 2, we're going to use our chickflick.sav file from chapter 3, and we are going to find out if there's a relationship between gender and arousal. We know that gender is a categorical variable with just two categories. One is male, two is female. And it doesn't really matter what you provide as a label here, because SPSS will automatically just change male to 0 and female to 1 and run the process. If you want to do the bootstrapping, it tends not to work on the basic programs that you can get in SPSS through Utah State University. It's considered an add-on that you have to buy and include in the package for SPSS. So I'm going to show you what it looks like without it and then what it looks like with it. And you'll still be able to do the same analysis, but bootstrapping will just make it a more robust process, because what they do is run about 1,000 different samples, and then they do this random process. And so every time you run the analysis, it'll be slightly different, but they take all of those 1,000 samples, and then they'll report for you what the correlation coefficient is between the two variables. And so what we're going to do is just go to Analyze. Since we can't do the bootstrapping strategy, we're going to go to Correlate. We're going to go bivariate. We're going to move the variable of gender and psychological arousal here. Since this is a form of the Pearson product moment correlation, we're going to have Pearson selected. You will have two-tail clicked. You can do the flag significant correlations, and then for your options, if you want the mean and standard deviation, you can have it. If you would like the cross product deviation and covariances, you can, but you don't need this option to be able to report the data accurately. So you just hit continue, hit OK. In the output, you're going to get your table. So your table is going to show you that you have no significant relationship between gender and arousal. And that's because when you look at our p-value, it is 0.266, which is larger than 0.05. And you have, a negative minimal relationship, so it's not even significant. Now what I'm going to do is show you how this looks as the write-up in APA style. In this situation, when you can't do the bootstrapping, you can still report the correlation coefficient and your probability value. So your write-up would state there is no significant relationship between gender and arousal. Use a comma, and then you're going to have RPB, that's for Point-Biserial, and you use R because that is the Pearson correlation symbol. You do an equal sign, and then you will type in negative 0.18. You do no zeros before a decimal point for a correlation coefficient, and you only report 2 decimal places. So then for the probability value, you'll do no zero before your decimal point, and we will just type 0.266, and it's best to report the actual value when it's possible. Only in situations if you have significance and it is 0.00, can you do p is less than 0.001, and you don't need that equal sign with the exact probability value. Now, in the event that we do have the bootstrapping strategy, your data will look a little bit different in the output, as shown here in the slide. What the big difference is going to be is with your bootstrap confidence interval. You can calculate your confidence interval anyway, but this provides it to you, so it gives you the lower and the upper values. So you can provide your correlation coefficient, your confidence interval, and your probability value in your write-up. So let's take a look at how that's slightly different. We can use the same verbiage as there was no significant relationship between gender and arousal. We'll do R with the little PB for Point-Biserial equals negative 0.18. Then we'll have the confidence interval. So you actually put the confidence interval with the upper and lower levels in the brackets, and you do your lower level first and then your upper level. And then because it uses the bootstrapping strategy, you have to say 95% bootstrap, which is BC, and then CI for confidence interval. So that's just letting you know that you have a bootstrapped confidence interval. And then you have your probability value. That's the exact value of 0.266. I'm now going to share with you another example of how to run a Point-Biserial in SPSS. This is a take on task 6 of chapter 7. To set up the scenario, we were asked to look at the data from people who have been forced to marry goats and dogs and measure their life satisfaction and how much they like animals using the goats or dogs SAV file. Is there a significant correlation between life satisfaction and the type of animal to which a person was married? Now, when I looked at this scenario, I wasn't too happy about the context, but I like the statistical principles that are taught. And so I'm going to give you a little bit of the context and how Andy Fields came up with this story. So he was taken by 2 different news stories. The first news story was about a Sudanese man who was forced to marry a goat after having been caught having sex with it. And then he found another story in which an Indian man was forced to marry a dog to atone for stoning 2 dogs and stringing them up in a tree for 15 years earlier. So he was a little perplexed about, the idea of whether a man should marry a dog if he has a history of violence toward dogs. But he wanted to know whether a goat or a dog made a better spouse. So he found some other people who have been forced to marry goats and dogs and then measured their life satisfaction and how much they like animals. What I'm going to do is walk you through the process of this SPSS statistics and how we're going to go about analyzing the data for this scenario. Okay. In SPSS, we're going to do a point-biserial correlation for our scenario by going to Analyze, Correlate, Bivariate. We are going to move type of animal wife as our one categorical variable. That's 2 categories of either goat or dog. And then life satisfaction. Since it is a type of Pearson product moment correlation, we'll have this correlation coefficient checked. We'll do a 2-tailed analysis and flag significant correlations, and then click OK. In the data, you will see our correlation right here, and you'll see the data is actually repeated twice in every correlation table. You just have to pay attention to the top half because it's repetitive in what it reports. So here we actually have a Pearson product moment correlation of 0.630, and this is significant because our p-value is less than 0.05, and so we could look at this as, if goats have been coded a 1 and dogs have been coded a 2, it would reflect the fact that maybe as wife goes up, it changes from 1 to 2, life satisfaction goes up. Or put it in another way, as the wife changes from being a goat to being a dog, your life satisfaction increases. So in general, marrying a dog gives rise to a greater life satisfaction. Let's take a look at how we would actually report that in APA style. So for our write-up, we can indicate that a significant relationship exists between the type of animal wife and life satisfaction. We'll report the point-biserial correlation of 0.63. We only report 2 decimal places, and we do not include a 0 before the decimal point because you can't have a correlation greater than 1. And then we will report the exact probability value of 0.003. And then I went ahead and calculated the coefficient of determination, or R squared, and that tells you your variability. And so what you do is you look at R being 0.63. Well, you can calculate the variability and life satisfaction that is shared with the type of animal wife when is married. And you do this by squaring R to get 0.397. So, to better understand variance or variability, you can make this a percentage. You will actually multiply 0.397 times 100 and you will get 39.7%. So the type of animal wife would share 39.7% of the variance in life satisfaction. If you are using the bootstrapping strategy to place, I would say, a greater emphasis on your data and make it more robust and stronger as your data, then this is what your correlation table would look like. You'll notice that the only thing different is going to be down here where they report the bootstrap. And the only thing you need to pay attention to is the 95% confidence interval for the bootstrap, and you report the lower and the upper brackets. So to do that, the only addition we make is right here with the confidence interval. We'll just type 95% BCCI. So that's 95% bootstrap confidence interval. And we'll do our lower and upper levels of our confidence interval. And we'll interpret it the exact same, showing that there's a significant relationship between the type of animal wife and life satisfaction. We know this by the level of our p-value being less than 0.05 and that our bootstrapped confidence interval does not cross zero when you look at the two values.